Hey guys, Mr. Rees here, Algebra 2, talking about sections 4.3 and 4.4 together. We're going to talk about factoring and then how to solve by factoring today. So there's a bunch of methods of solving that we will cover. These are all for quadratics, and we're going to talk about factoring today. The rest we will get to in later lessons. So we're going to break this up into two parts. Part one will actually factor, show you the different ways to factor, and then part two will solve by using those factoring methods. So two parts here. Part one, factoring. There's a bunch of different kinds of factoring. These first four is what we will do in this chapter, and the next chapter covers a few other kinds of factoring, so they're listed there as well. Greatest common factor. You're probably pretty familiar with this. We call this the GCF. You just take out what's common, put this out in front. This number out here, that's called the GCF, greatest common factor, and then you just leave it, and then you're done. Example 2, something pretty similar. Take out a GCF. Again, this 8 is common to all. You could go through and explain why this is. 8 divides by 32 and 24. It's the largest number, the greatest number that divides by both of those. As far as the exponents, when you see 5 and 3, you want to take out the least exponent. So there's 3 that you can take out, so that goes here, and then you subtract. So 5 minus 3, that's why that exponent is 2. 3 minus 3 is why there's none left here. On this one on the left side, there's no x's you can take out, just the 5. And again, you notice 5 divides by all three of those. So it's called the GCF. Difference of squares is another method, pretty common. Here's the rule that the book will give for factoring. And so this is just kind of a FOIL process to kind of show you why this works. If you take this thing, the answer, and FOIL it, you get these terms. Well, you notice these two middle terms cancel out, and you're just left with the a squared minus b squared. So that's why it works. Here's an example. When you go to difference of squares, this is a square, and it's a subtraction, so you can use this method, and it's x plus 5, x minus 5, and you're done. It's a real quick hitter. Same for this example. You're going through 9's a square, x squared is a square, 16's a square, so you can use this method, and you can talk about, okay, so 3x plus 4 and 3x minus 4. 3 is the square root of 9, and 4 is the square root of 16, which is where those numbers come from. As we move on here, as we kind of talk about grouping. So grouping is when you have 4 terms, really any even number of terms. We're going to divide this problem in half down the middle. And so when we go through, what will happen is we take out the GCF from the left side. When we look on the left side, this 5x squared represents the greatest common factor on the left. On the right side, we do the same thing. We say, we take the GCF here, the GCF is 6. We can know if we're doing this right, these should match. X minus 2's on both, so we know we're doing it right, and we'll just go ahead and list the two factors. One factor is already listed there for you, x minus 2, and when you get rid of that, the other factor that's left is here, 5x squared plus 6. So those are your two factors. That's grouping. Next method here is called the AC method. So when you only have 3 terms, we still want to actually use this grouping idea, but we're going to have to split the middle 2 terms. So we're going to take this 7x and split it. So we start off by multiplying a times c. So this is the value of a is 2, the value of b is 7, the value of c is negative 15. So we take and multiply a times c and get negative 30. After we're done with that, we try to find 2 factors of AC that add up to b. So you can list all the factors of 30 if you want to do the whole factor tree thing, 1 and 15, and oh, that would be 2 and 15, 2 and, oh, we already used 2, 3 and 10, and let's see what else we've got, 5 and 6, and so here's all your factors. And so what happens here is this 3 and 10 works. 3 needs to be negative, because negative 3 times 10 multiplies up to negative 30, and they add up to a positive 7. So factors of AC that add up to B are negative 3 and positive 10. So we split the middle 2 terms. So this is kind of the main idea here. That's why we call it split the middle sometimes, is you take 7 and you split it to 10 and negative 3, because 10 minus 3 is still 7. Go through and split the middle term. Now it's just a grouping problem. So we'll go through the grouping idea. I'll say, all right, we'll take the GCF out of the left. You'll notice that's 2x. So 2x is the GCF on the left side. And on the right side, 3 and 15. So 3 is the GCF on the right side. And again, it's just a grouping problem. So those two go together to make one factor, and then x minus 5 is the other factor. Once again, here, look, these two have to match. X plus 5 have to match. If they don't match, then we didn't do it right. So those are all the methods of solving here. So as we kind of go through now, all those are all the methods of factoring. Now we're going to solve. We're going to use this to solve. So here's the steps for solving by factoring. And so we'll kind of give you an example here. We got this problem. So it's a quadratic, meaning it has an x squared, and we're going to want to solve it. So the first thing we do is get it equal to 0. So we're going to, let's see here. Oh, this should be a 0. So we're going to subtract this 7x over to the other side. And so we get it all equal to 0. I screwed up on the problem, by the way, just so you know. Then we go ahead and factor it. So we say, hey, we know how to do this. This is the AC method. We need numbers that multiply up to 10 that add up to -7. So that's -2 and -5. We go ahead and factor those. Awesome. Once we factor them, we can set each of the things equal to 0. So there's step 3. Set each of them equal to 0, and then go ahead and solve each of them. Okay, so if you know how to factor, this process is actually pretty easy. Give you another example here. So we're going to deal with this. It's already equal to 0, so that's great. We're going to go ahead and factor it. So there's the GCF coming out. We actually can factor this more. This is the difference of two squares. We'll set each of these factors equal to 0. Once you set each of these factors equal to 0, then we can go ahead and solve each one of them. And so this one actually has 3 answers. Has 3 answers because this is an x to the third power problem. All right, so you should be able to factor any polynomial that's given to you, and you should be able to solve equations by factoring. Hopefully you know how to do that now. So thanks.